Hello my dear children, welcome to the mathematics class. Today we are going to discuss integrals. In this chapter we are going to discuss the concepts of exercise 7.11. In the previous class we have discussed the concepts of exercise 7.10 and we have completed the sums in the exercise 7.10. I hope you have understood the concepts well. I hope you have learnt well the concepts. Okay, my children, haven't you? Right. Now come to these concepts of exercise 7.11. Are you ready to listen the class? Right. See here some properties of definite integrals. In the previous exercise by substitution we have evaluated definite integral of a given function by substitution. Aren't you? Right. By using these properties we can evaluate definite integrals some little easier. Okay, my children, without using these properties also we can evaluate definite integrals of a given function, but with the help of these properties, with the help of these formulae, we can evaluate definite integral of a given function very easily. Okay, my children, that is why we are going to learn these properties. See the first property, integral a to b f of x dx is equal to integral a to b f of t dt. Okay, my children, this is the first property. This property was already used in this exercise 7.10 in the substitution. We have substituted with some function and we have evaluated and we took the same limits, lower limit and upper limit. After evaluating the indefinite integral, we substituted upper limit minus lower limit. Okay, Mitchell, this is the first property we have already used in the exercise 7.10. Okay, Mitchell, now come to the second property. Integral a to b f of x dx is equal to minus integral b to a f of x dx. See, observe this formula, Mitchell. Here lower limit is a, upper limit is b. But here in the reverse order, b is lower limit, a is the upper limit. In this case, we take its additive inverse. So integral a to b f of x dx is equal to, if we are reversing, we are replacing the limits, lower limit and in upper limit. If you interchange them, then we take minus integral b to a f of x dx. Okay, my children, understood this formula? And in particular, integral a to a f of x dx is equal to 0. If lower limit and upper limit both are same, then the definite integral of that function is equal to 0. Okay, my children, right. Come to the third property. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x. In the place of x, we write the lower limit and upper limit as it is, but in the place of x, we add these two, lower limit and upper limit minus x. We replace x in the function by a plus b minus x dx. Okay, my children, we use this property very frequently in evaluating definite integral of a given function. Remember this formula, my children. Similarly, fourth, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is nothing but a particular case of this third formula. Here a is equal to 0 and b is equal to a. See this one, 0 plus a minus x. Yes or no, my children? Same, both are same. This is nothing but a particular case of this formula. Okay, my children? Right. Now come to the fifth one. Integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to x. First of all, we have to find this value. If this condition is satisfied, then we can write here 2. We have to write this number 2 here, and we write 0 to a f of x dx. Okay, my children. Otherwise, its value is 0 if f of 2a minus x is equal to minus x. If this condition is satisfied, then the value of this definite integral of this function is equal to 0. Okay, my children. Right. Now come to the sixth one. Integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f of minus x is equal to f of x. Observe here, my children, this is negative and this is positive. Minus a to a. In this case, first of all, we have to find f of minus x value. If it is equal to f of x, then the definite integral is equal to 2 into integral 0 to a f of x dx. Okay, my children. In the second case, on the other hand, if f of minus x is equal to minus f of x, then the value of this definite integral of this function is equal to 0. Okay, my children. So most of these cases, in the out of all these 6 formulae, remember this formula, second, third and sixth. These 3 are very, very important. Okay, my children. Second, third and sixth. Second, third and sixth. These are very important formulae. Remember these 3 formulas well. Learn these formulas well, my dear children. Memorize these 3 formulas. Okay, my dear children. Right. Concepts of exercise 7.11 were completed. They were finished. Only those formulae, only those 6 formulae are enough. You have to learn well, my dear children. You have to memorize that 6 formulae well. Okay, right. Now come to the sums of exercise 7.11, page number 347 in the textbook. Okay, my dear children. Let us start the sums in the exercise 7.11. Come to the question number 1. By using the properties of definite integrals, evaluate integral 0 to pi by 2 cos square x dx. Understood this question, my children? Here it is mentioned clearly. We have to use the properties of definite integrals to evaluate this definite integral of this function. Okay, my children, you must use the appropriate properties of definite integrals to evaluate this function. Okay, my children, right. Come to the solution part. Let us assume that capital letter I is equal to integral 0 to pi by 2 cos square x dx. Okay, my children, you know this is first step. In this entire chapter, first step, we are assuming that capital letter I is equal to integral of the given function. Okay, my children, let us assume that this is equation 1. Okay, my children, right. Now, here I am applying g into 0 to pi by 2 cos square of pi by 2 minus x dx. Definite integral formula. I am using this definite integral formula. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, where a is equal to pi by 2. Where a is equal to pi by 2. So a minus x means pi by 2 minus x. In the place of x, I wrote here pi by 2 minus x. Understood this step, my children? By using this definite integral property, I wrote this step. Okay, my children? Right. That is equal to integral 0 to pi by 2 cos square pi by 2 minus x. Cos pi by 2 minus x. What will you get? Sine. So sine square x dx. Because cos pi by 2 minus x is equal to sin x. Cos 90 minus theta, sin theta. Okay, my children, by using this formula, we get sin square x. Okay, my children, understood this one? Let us consider this is second result. This is second result. Let us consider this is a second result. Because cos pi by 2 minus x is equal to sin x. Okay, my children, this is also I. Okay, my children, we got this result. We assumed here this result is equation 2. Now let us add equation 1 and equation 2. Adding 1 and 2. Adding 1 and 2. We get 2i. I plus I. What will get in LHS? 2i is equal to integral 0 to pi by 2 cos square x dx plus integral 0 to pi by 2 sin square x dx. We are adding these two RHS parts. Okay, my children, understood? Right. That is equal to, see this limits 0 to pi by 2, here also 0 to pi by 2. So we can write as one function, integral 0 to pi by 2 cos square x plus sin square x dx. Yes or no, my children? If this is given, we can split into two terms. If two terms are written, we can write it as one function. Yes or no, my children? Right. That is equal to integral 0 to pi by 2. What is the value of sin square x plus cos square x? 1 dx. See how much simply this one here, sin square x plus cos square x is equal to 1. Sin square a plus cos square a is equal to 1. By using this trigonometric identity, we got here 1. Integral 1 dx. What is the value of integral 1 dx? X. Yes or no, my children? Limits 0 to pi by 2. Because integral dx is equal to x. Understood this step, my children? See how much easier to evaluate this definite integral by using the appropriate properties of definite integrals. Okay, my children? Right. This implies 2i is equal to x from 0 to pi by 2. Here upper limit is pi by 2 and the lower limit is 0. Okay, my children? Right. 2i is equal to, in this function first we have to apply pi by 2 upper limit minus lower limit. This is the indefinite integral value. We got answer. In this answer we have to substitute upper limit minus lower limit. Understood this step, my children? Right. This implies 2i is equal to pi by 2. Pi by 2 minus 0. What will you get? Pi by 2. From this equation we find I value. So I is equal to 1 by 2 into pi by 2. This becomes 1 by 2. If you are transforming, if you are transposing this 2 to RHS, it becomes 1 by 2. Okay, my children, this implies I is equal to pi by 4. Okay, my children, like this we can evaluate the definite integral value of a given function by using appropriate definite integral properties. Okay, my children, understood? Right. Now come to the question number 2. By using the properties of definite integrals, evaluate integral 0 to pi by 2 root sin x whole divided by root sin x plus root cos x dx. Here also we have to evaluate definite integral of this function by using the properties of definite integrals. Okay, my children, understood this question? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 0 to pi by 2 root of sin x whole divided by root sin x plus root cos x. Okay, my children. Here also we follow the same steps as we followed for the first question. Let us consider this is result 1. Okay, my children. Right. Here also we use the same property as we have used the same property we used here. Integral 0 to pi by 2 sine of pi by 2 minus x whole divided by, in the place of x we are writing pi by 2 minus x whole divided by square root of sine pi by 2 minus x plus root of cos pi by 2 minus x dx, because integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. By using these properties of definite integral, we wrote this step where a is equal to pi by 2. So in the place of x, we wrote a minus x in the given function. Understood this step, my children? By using this property, we wrote this step. Okay, my children? Right. Is equal to 0 to pi by 2 square root of, here what will get, sin pi by 2 minus x, sin 90 minus x, cos x. Yes or no, my children? Whole divided by square root of cos x plus square root of what we get here, cos pi by 2 minus x, sin x. Understood, my children? Because sin pi by 2 minus x is equal to cos x, cos pi by 2 minus x is equal to sin x. By using this trigonometric properties, sin pi by 2 minus x is equal to cos x, cos pi by 2 minus x is equal to sin x. By using these trigonometric identities, we wrote this step. Understood this step, my children? Let us consider this is result 2. Okay, my children? Let us consider this is result 2. Now let us add 1 and 2. Let us assume here also I. All these are equal to I. So adding 1 and 2. Adding 1 and 2. We get 2i is equal to I plus I. I plus I. We get 2i is equal to integral 0 to pi by 2 root sin x by root sin x plus root cos x plus integral 0 to pi by 2 root cos x by root cos x, just I will write in the reverse order, root sin x plus root cos x dx. Can we write it or not, my children? We can write in the reverse order or not. That is why I wrote root sin x plus root cos x in the denominator. Understood this step, my children? Right. This is equal to integral 0 to pi by 2. See here, limits are same, 0, 0. Here also pi by 2, pi by 2. So we can add these two numbers. Okay, my children? So root sin x by root sin x plus root cos x plus root cos x by root sin x plus root cos x dx. Understood this step, my children? Here limits are same, 0 to pi by 2. Here also 0 to pi by 2. So we can add these two terms. We can write as one function. Okay, my children? Understood? Right. So by taking the LCM of the denominators, we get root sin x plus root cos x is the LCM for the denominators of the two fractions. Then in the numerator we get root sin x plus root cos x. Okay, my children, understood this numerator part? Right. If you observe this fraction, numerator root sin x plus root cos x, denominator also root sin x plus root cos x. Both numbers will get cancelled. This implies 2i is equal to integral 0 to pi by 2 1 dx. After cancellation, we get here 1 dx. Understood this step, my children? Right. This implies 2i is equal to integral 1 dx. What is the integral 1 dx? X. Limits 0 to pi by 2. Because integral 1 dx is equal to x. By using this formula, we got this part. Understood this step, my children? Limits 0 to pi by 2. Now in this function, we write upper limit minus lower limit. Okay, my children? Right. So 2i is equal to pi by 2 x. In the place of x, we write pi by 2 minus lower limit 0. Understood this step, my children? Right. This implies 2i is equal to pi by 2. This implies I is equal to, if we transpose number 2 to RHS, we get pi by 4. So this is the definite integral of the given function. Okay, my children. Similarly, question number 3, question number 4 also same procedure. Follow the same steps as we followed for this question. Okay, my children, will you try the question number 3 and question number 4? Please try yourself the question number 3 and question number 4. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children, right. Now come to the question number 5. By using the properties of definite integrals, evaluate integral minus 5 to 5 modulus of x plus 2 dx. Understood this question, my children? Here also we had to use the properties of definite integrals. By using the properties of definite integrals, we have to evaluate minus 5 to 5 integral modulus of x plus 2 dx. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral minus 5 to 5 modulus of x plus 2 dx. Okay, my children? Right. Here modulus function is there. Absolute value function. Let us redefine this modulus function in different intervals. Okay, my children? Right. See, modulus of x plus 2 is equal to x plus 2 if x plus 2 is greater than 0. Yes or no, my children? Modulus of x is equal to x if x is greater than 0. We are using the modulus function definition here. Yes or no, my children? Means that is x greater than minus 2. If x is greater than minus 2, we can take modulus of x plus 2 is equal to x plus 2. Understood, my children? Right. Similarly, modulus of x plus 2 is equal to minus of x plus 2 if x plus 2 is less than 0. Do you remember the definition of modulus function, my children? Modulus of x is equal to minus x, where x means x plus 2. Okay, my children? So, modulus of x is equal to minus x if x is less than 0. This implies that is x is less than minus 2. Understood this part, my children? So, in this interval, if x is greater than minus 2, we have to take modulus of x is equal to x plus 2. In this interval, if x is less than minus 2, modulus of x is equal to minus of x plus 2. See, on the number line, here minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, my children? Here minus 5 to 5. Okay, my children? Here x is equal to minus 2. See, at this point, this function is defined into two different intervals. If x is less than minus 2, modulus of x plus 2 is equal to minus of x plus 2. Yes or no, my children? If x is less than minus 2, modulus of x is minus of x plus 2. If x is greater than minus 2, right side of this number, modulus of x plus 2 is equal to x plus 2 only. Modulus of x plus 2 is equal to x plus 2. Understood this step, my children? Right. Therefore, I is equal to integral. We write this entire interval into two intervals. Minus 5 to minus 5 to minus 2, minus 5 to minus 2. In this interval, what is f of x here? What is f of x here? So in this interval, minus 5 to minus 2, integral minus 5 to minus 2, f of x is defined as minus of x plus 2, minus of x plus 2 dx, plus integral minus 2 to 5, integral minus 2 to 5. In this interval, modulus of x plus 2 is defined as x plus 2 dx. Understood this step, my children? We are splitting this modulus function into two intervals like this. Okay, my children? Here this is a property, integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where a less than c less than b. So between a and b, a point c is there. If a point c is there between a and b, then we can split into two integrals like this, a to c plus c to b. Okay, my children, by using this property, we wrote this step where a is equal to minus 5, c is equal to minus 2 and b is equal to 5. So integral minus 5 to minus 2 f of x dx plus minus 2 to b 5 f of x dx. Understood this step, my children? Right. Now let us evaluate here. Minus 5 to 5, 5 to minus 2, x plus 2 dx. Let us find the integral of this function. What is integral x dx? I am writing here directly. What do you get? Integral x dx, x square by 2 plus integral 2x. What do you get? 2x. Yes or no, my children? Because integral x dx is equal to x square by 2, integral x power n formula, x to the power of n plus 1 by n plus 1. I used that formula, integral x to the power of n dx is equal to x power n plus 1 by n plus 1, and integral dx for this second term, 2 is numerical coefficient, then we get integral dx is equal to x. Understood these two terms, my children? Right. Here I wrote the last step again here. That is equal to minus of, what you get here, x square by 2 plus 2x. Integral x dx, x square by 2 plus integral 2 dx, 2x. Okay, my children? The same integral. Okay, my children? Minus 5, lower limit is minus 2 and upper limit is minus 2 plus here x square by 2 plus 2x minus 2, 5. Okay, my children? In this step, understood this step, my children? Now we substitute upper limit minus lower limit in this function. Similarly here also upper limit minus lower limit. Okay, my children, that is equal to minus of, first we substitute upper limit minus 2 whole square by 2 plus 2 into minus 2. This is upper limit minus, what is lower limit? Minus 5. So minus 5 whole square by 2 plus 2 into minus 5. In this function, we have substituted upper limit. We get these two terms minus, by substituting by substituting the lower limit, we get minus 5 whole square by 2 plus 2 into minus 5. Understood these two terms, my children? Right. Similarly, for this function, we apply upper limit minus lower limit. 5 whole square by 2 plus 2 into 5. In this function, I substituted upper limit 5 minus 2 whole square by 2 plus 2 into minus 2. In the same function, I substituted lower limit. Understood this step, my children? Right. Now let us simplify the numbers. That is equal to minus of, what you get here? Minus 2 whole square by 2. Minus 2 whole square value is 4. 4 by 2. 2. 2 minus 4. Understood these two terms, my children, in this set brackets. Right. Minus, what you will get? 25 by 2 minus 2 whole square. 25 by 2 minus 10. Understood these two terms, my children, in these brackets. Plus, what will get? 5 square by 2. 25 by 2 plus 10. Understood these two terms, my children? From these brackets we wrote these two terms. Minus of, what will get here? Minus 2 whole square. 4 by 2. What will get? 2 minus 4. 2 into minus 2 minus 4. Okay, my children, understood this step? Right. That is equal to minus of, that is equal to minus of, what will get here? Minus 2 minus 2. Here what will get? Minus 25 by 2 plus 10. Okay, my children. Plus, what will get here? 25 by 2 plus 10. What will get? 2 minus 4 minus 2. Minus of minus 2 plus 2. Understood this step, my children? Right. That is equal to minus of 10 minus 2, 8 minus 25 by 2. Okay, my children, understood these two terms in these brackets. Plus 25 by 2 plus 10 plus 2. What will get? 12. Okay, my children, understood? Right. Now, let us multiply by minus. What will get? Minus 8 plus 25 by 2 plus 25 by 2 plus 12. Understood this step, my children? Right. Then what will get here? 25 by 2 plus 25 by 2. We get to 25 plus 12 minus 8. What will get? 4. That is equal to 29. Okay, my children, understood? Right. Question number 7, question number 6 and question number 18. Question number 6 and question number 18 are also same as that of this question number 5. Follow the same steps and evaluate the definite integral of the given modulus function. Okay, my dear children, modulus functions are given in the question number 6 as well as in the question number 18. Okay, my dear children, please do yourself, try yourself these question number 6 and question number 18. Will you try yourself, my dear children, these two questions? Please try yourself these questions. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right. Now come to the question number 7. By using the properties of definite integrals, evaluate integral 0 to 1 x into 1 minus x whole power n dx. Okay, my dear children, understood this question? Here also we have to evaluate this definite integral by using the properties of definite integrals. Okay, my dear children? Right. Now come to the solution part. Let us assume that capital letter I is equal to integral 0 to 1 x into 1 minus x whole power n dx. Okay, my dear children? Right. That is equal to integral 0 to 1. Here also I am applying integral 0 to a f of x dx is equal to integral 0 to a f of a minus x, upper limit minus x. Okay, my dear children? So 1 minus x into 1 minus of 1 minus x whole power n dx, because integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That is why I told you previously when we are discussing the concepts of this exercise 7.11. This formula is very important. Okay, my children. So in the place of x, we wrote upper limit minus x. Here x is there, so upper limit is 1. So 1 minus x. Here also x is there. I wrote 1 minus x in the place of x. Understood this step, my children? By using this property of definite integral, we wrote this step. Okay, my children? Right. That is equal to integral 0 to 1, 1 minus x into what we will get 1 minus 1 plus x whole power n dx. By using the distributive property, we get minus 1 plus x. Understood this step, my children? Right. Here plus 1 minus 1 gets cancelled. That is equal to integral 0 to 1, 1 minus x into x power n dx. Yes or no, my children? Understood this step? Right. Again we use distributive property. That is equal to integral 0 to 1, 1 into x power n. What you get? X power n minus x into x power n. What you get? X power n plus 1 dx. Understood this step, my children? By using the laws of exponents, we added powers of x. Then we got n plus 1. Understood this step, my children? Right. That is equal to integral x power n formula, x power n plus 1 by n plus 1 minus integral x power n plus 1 dx. What you get? X power n plus 2 by n plus 2. Understood the second term, my children? Integral of this term, integral x power n plus 1 dx is equal to x power n plus 2 by n plus 2. Integration part is over. We substitute limits, lower limit and upper limit. Let us substitute upper limit in this function. What you get? 1 power n plus 1, 1 by n plus 1 minus, in the place of x we write upper limit 1 by n plus 2 minus. Understood this step, my children? In this function we are substituting x is equal to 1. 1 power n plus 1, what you get? 1 only in the numerator. I wrote the value of numerator as directly by n plus 1 minus here also 1 power n plus 2, 1 only. So in the numerator I wrote 1. Understood this numerator, my children? By n plus 2 minus. Now we substitute lower limit 0 power n plus 1, what you get? 0. 0 by any number we get 0 minus. Here also we substitute x is equal to 0. 0 power n plus 2. What you get? 0 power n plus 2. 0 by n plus 2. 0. Understood, my children? Right. Now let us simplify. What you get? N plus 1 into n plus 1 into n plus 2. LCM of these two denominators is n plus 1 into n plus 2. In the numerator what you get? N plus 2 minus n minus 1. Just by multiplying this function. Understood this step, my children? Right. Then plus n minus n gets cancelled. In the numerator what you get? 1 by n plus 1 into n plus 2. This is the definite integral of the given function. Understood, my dear children? Right. Similarly, the next question also. Question number 9. Question number 9 also same as that of question number 7. Okay, my children? Do the question number 9 also same as that of question number 7. By using this property, by using this definite integral property. Do the question number 7 also yourself, my dear children. Please try it. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right. Now come to the question number 8. By using the properties of definite integrals, evaluate integral 0 to pi by 2 log of 1 plus tan x dx. Okay, my dear children, understood this question? Here also we have to use the properties of definite integrals to evaluate this question. Okay, my dear children, right. Now come to the solution part. Let us assume that capital letter I is equal to integral 0 to pi by 2 log of 1 plus tan x dx. Let us consider this is equation 1. Okay, my dear children, right. That is equal to integral 0 to pi by 2 log of 1 plus pi by 4 log of pi by 4 1 plus tan of pi by 4 minus x dx. By using this property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, where a is equal to pi by 4. Okay, my children, here upper limit is pi by 4. So in the place of x we wrote pi by 4 minus x by using this property. Understood this step, my children? Right. That is equal to integral 0 to pi by 4 log of 1 plus, this is in the form of tan of a minus b, tan of a minus b, tan a minus tan b by 1 plus tan a tan b. Okay, my children. So what you get? 1 minus tan pi by 4 is 1, tan a minus tan b, that is tan x by 1 plus tan pi by 4 is 1 into tan x. Okay, my children, I wrote directly here dx because tan a minus b is equal to tan a minus tan b by 1 plus tan a tan b. By using this trigonometric identity, we wrote this step. Tan pi by 4 is 1. Okay, my children, understood this step? Right. That is equal to integral 0 to pi by 4 log, let us take LCM here, 1 plus tan x. What you get here? 1 plus tan x plus 1 minus tan x. In the numerator, we get these terms. Understood these terms, my children? This is a LCM of the denominators. Then we got 1 plus tan x. In the numerator, we get 1 plus tan x plus 1 minus tan x. Understood this step, my children? Right. Here plus tan x minus tan x gets cancelled. Until 0 to pi by 4 log of 1 plus 1. What you get? 2 by 1 plus tan x dx. Understood this step, my children? In the numerator, we get 1 plus 1, 2 by, we wrote the denominator as it is. Okay, my children? Now, if you observe this function, it is in the form of log of a by b. We use the logarithm property here. Integral 0 to pi by 4 log 2 minus log of 1 plus tan x dx, because log a by b is equal to log a minus log b. Okay, my children, by using this logarithmic property, I wrote these two terms. Understood this step, my children? Right. Now let us split into two integrals. That is equal to integral 0 to pi by 4 log 2 minus integral 0 to pi by 4 log of 1 plus tan x dx. We have split it into two integrals. Okay, my children? Pi by 4. If you observe this second term, it is nothing but integral 0 to pi by 4 log of 1 plus tan x dx. Means it is nothing but I. Okay, my children? Understood? Right. this implies I is equal to integral 0 to pi by 4 log 2 dx minus I from the equation 1, because integral 0 to pi by 4 log of 1 plus tan x dx value is I. So we wrote this step. So understood this step, my children? Right. Now transpose this minus I to LHS. Then what you get? I plus I is equal to, here log 2. This is a numerical coefficient. We can write it outside. Log 2 into integral 0 to pi by 4 dx. Understood this step, my children? Right. This implies 2i, I plus I. What is the value of I plus I? 2i is equal to log 2 into integral dx. What is the value of integral dx? X. Limits 0 to pi by 4. We have found the integral of this function and we are writing lower limit and upper limit. Understood this step, my children? Right. That implies 2i is equal to log 2 into, in this function let us substitute upper limit minus lower limit, pi by 4 minus 0. X is there in the place of x, we write upper limit pi by 4 minus lower limit 0. Understood this step, my children? Right. This implies 2i is equal to log 2 into pi by 4. Understood this step, my children? Right. This implies I is equal to, we write first here, pi by 8, because it becomes by 2. 1 by 2 into 4. We get pi by 8 into log 2. So this is the definite integral of the given function. Understood, my dear children? Right. Please try the remaining questions in this exercise 7.11. Try yourself the remaining questions in the exercise 7.11 which were not explained in this video. Okay, my dear children? If you have any doubts, ask your doubts and get your doubts clarified. In the next class, I will start a new chapter. Okay, my dear children? Right.